Okay, so in this video we're going to take a look at 5-number summaries, checking for outliers, and making box plots. All right, here we have a data set below, shows us the scores on a college entrance exam, and we're asked to complete a few different things here. So let's start with part A, find the 5-number summary. All right, so first I guess we have to know what is it that they're asking us to find in a 5-number summary. They want us to find the minimum data value, the first quartile or the lower quartile, we abbreviate it Q1. The second quartile, which is the same thing as the median. The third or the upper quartile, Q3. And then the maximum data value. In order to do that, we should put our data set arranged from smallest to largest. All right, so 225 is the smallest, 230, 240, 248, 260, 270, 285, 290, 300, and then finally at 330. So we kind of get two of them for free here. We get the min and the max essentially for free. Now, in order to find these middle three, in order to find the quartiles, this is what we're going to do. We're going to find the median first. So here we got 10 data values. So we're going to go 1, 2, 3, 4, 5, and right between the 5 and the 6, that's going to be our median. All right, so our median's 265. That means all of these values down here, below the median, that's called our lower half. The first quartile is going to be the median of the lower half. So median of the lower half, 240, that's my Q1. The data values to the right of the median, this is our upper half. The median of the upper half is what we're going to use for Q3. So we have a 5-number summary of 225, 240, 265, 290, and 330. For part B, we're asked to find the interquartile range and identify any outliers. All right, the interquartile range is pretty straightforward. It is equal to the difference Q3 minus Q1. So let's see, Q3 is 290, Q1 is 240. So here we get an IQR of 50. The IQR tells you basically the spread of the middle 50% of your data set. This tells me the middle 50% of these scores are within 50 points of each other. What we want to do here is use the IQR to identify outliers. Sometimes there are no outliers, sometimes there's one or two, and they might be at the high end or the low end. If you're ever asked to find outliers, show me the work. We have formulas in our book to identify fences, which are basically cutoffs. So LF, the lower fence, is my abbreviation for the lower fence. We have a formula in our book that's equal to the first quartile minus 1.5 times our interquartile range. So here that would be 240 minus 1.5 times 50. So let's see, that would be 240 minus 75. So it looks like we have, oops, what's a funky looking 1. So 240 minus the 75 is going to give us a 165. What that means is if we had any data values less than 165, they'd be outliers. Here, the lowest one was 225, so we have no outliers on the low end. All right, we also have a high cutoff point, an upper fence, which is the third quartile plus 1.5 times the IQR. So in this case, the upper quartile, or the third quartile, is 290 plus 1.5 times 50. That would be 290 plus 75. So that would be 365. Well, we have 330 as our max, so there are no high-end outliers either. So there are no outliers. It's a little bit problematic. Some people try to just look at a data set and figure out visually if there's an outlier or not. But again, if I ask you to show work to find any outliers, this is what you got to do. All right, now that we know there are no outliers and we have our 5-number summary, we are ready to do the box plot. All right, to start the box plot, I'm going to get a number line going on here. And I want to scale the number line to make sure everything fits in. As you can see, I don't have perfectly evenly spaced tick marks, but they're reasonably equal distances. I'm going to start at 220. As I was marking them off, I was counting by 10, making sure that we'd fit all of our data, meaning I need my 225 to fit somewhere, and I need my 330 to fit somewhere. It's very common for people to forget the title, so let's get a title up here. Get a title, and then, I could make the title college entrance exam scores, but since I just wrote college entrance exam, maybe I'll put score down here. This bottom part is where you would put unit. If something was measuring a weight, you could put it, tons or pounds. And then to draw the box plot, the box part is going to go from your lower quartile, Q1, up to your upper quartile, Q3. All right, so here Q1 was 240, Q3 was 290. So the box part goes from 240 to 290. Our median was 265, so at 265 we're going to have a line through the center of the box. And then in the case of no outliers, the whiskers extend to the max of 330 and down to the min, which was 225. All right, to give you notice, the way that I'm going to grade this, I check for a title. I check to make sure that we have a number line that looks like it's relatively evenly spaced and you're counting by the same amount. And then I check to make sure that your box plot is visually correct. If we're doing a problem by hand, I don't expect it to be absolutely perfect. What I do is basically look, and let's say we're looking at this min value here. It's supposed to be 225. Is that reasonably close to 225? Yes, it is. So good enough. All right, so this is all we would need for the first problem. All right, so taking a look at number 2, this one's a little bit more challenging because it doesn't lay the steps out. We have to know what to do to make the box plot. So it says the completion time in seconds for an obstacle course are shown below. Show the work in creating the box plot. All right, so basically we're going to do essentially the same thing. Let's put these in order. So let's see, I'm seeing 26, 29, a 31, a 35, a 36, I see a couple 40s, a 41, a 42, 50, 60, a 75, and a 90. Okay, so what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data values. So it's going to be a little bit different doing the 5-number summary. We still get the min for free. We get this max for free. This time we're going to have one single center number, the 7th value. So the 7th data value here is that 40. What that means is this set of numbers is our lower half. This set of numbers is our upper half. All right, let's take a look. What's the median of the lower half? Well, it looks like it would split between 31 and 35. So that's our Q1 is going to be 33. On the upper half here, looks like it splits between 50 and 60. So Q3 is going to be 55. Now, we got to find out if there are any outliers. We got to do the IQR in order to do that. Our IQR this time would be 55 minus 33. So I'm getting an IQR of 22. When I check for outliers, I set up my lower fence. Remember, that's going to be your Q1, 33, minus 1.5 times your interquartile range, which is 22. All right, well, that actually comes out to 0 if we calculate this. So there's no data value less than 0 here, so we have no outliers on the low end. Let's check the upper fence. The upper fence is going to be your 3rd quartile. Here it's 55, plus 1.5 times our interquartile range. So let's see, 55 plus 1.5 times the interquartile range is 22. So that's going to equal 88 for our upper fence. Well, we have a max of 90. That means we have an outlier, because it's above our upper fence. All right, so we'll have to see what we do here in order to adjust our box plot for an outlier. All right, I got my number line. I'm going to put down 20, 30, 40, 50, 60, 70, 80, and then 90. Okay, this was obstacle course times. The unit was seconds. So I got my labels down. Now we got to draw the box. The box goes from our 1st quartile, which was 33. Again, close enough to 33. And then it goes up to our Q3, which was 55. Our median was 40, so we got a line down the middle at 40. And there were no low-end outliers. So my whisker is going to go down to the lowest data value, which was 26. We have an outlier on the high side. So the way that we do this is an outlier is going to get graphed as a little asterisk in a box plot. So we're going to put an asterisk out at 90. This is the only thing that people tend to mess up on a box plot when we're drawing it by hand. When there's an outlier, the whisker will not go to the outlier. The whisker is only going to go to the largest data value that's not an outlier. Or if you had an outlier on the low end whisker would only go down to the lowest value that's not an outlier. So here, 75 is the highest value we see that is not an outlier. So the whisker will go to 75. This would be a good problem to try in a few days from scratch to see if you can replicate what we got. One of the features of this box plot that's worth talking about is take a look at the difference between the lower half from the median below versus the upper half. Right? We see that the left side of the box is significantly more compact than the right side. We also see that the left whisker is significantly more compact than the right whisker, and we even have an outlier. Right? This graph is more stretched out to the right. This would indicate that we have a skewed right distribution. So, things like looking at a bell curve or skewed left or skewed right, usually you use a histogram for that, but here we see a box plot that would indicate that the distribution is skewed right. All right, good luck working on the homework problems.